Yeah, so welcome to the first lecture of the course Soft Computing. So I'll be teaching you soft computing during this summer term. So basically, uh, yes, I'll be sharing the handout. But before that, I would like to say something. So I want you to refer this NPTEL website. So our course will be uh, our course flow will be based on this. Okay, so you can go to YouTube and you can just search this soft computing NPTEL, and there are NPTEL lectures for soft uh, by IIT Kharagpur. So there are 40 lectures where each lecture ranges from 25 to 30 minutes. So our course also will be based on this flow throughout, right? So I'll be creating lectures and I'll be sharing with you, but it will be based on this structure, right? Okay. So let us get into the first lecture. So in today's topic, these are the things we'll be discussing. So we'll be discussing the introduction to soft computing, and first we'll be discussing what is meant by computing. So there is a term soft computing. So first we'll be trying to understand what is meant by computing, what are the characteristics of computing, and then we'll be differentiating what is soft computing and what is hard computing. If there is something called a soft computing, then there should be something hard computing also. So what is that? What is hard computing? Okay, and we'll be discussing some examples of soft computing and characteristics of soft computing, and also we'll be defining what is meant by hybrid computing. So these are the things which we are going to discuss in this lecture. So to start with, what is computing? So you can see here. So basically, computing in the sense, it computing is something like a it is something like a processing. It takes an input. Here the input is called as antecedent, and that and that is getting computed. So here computing you can also call it as mapping. It is mapping. Computing can also be called as mapping an input to an output. Okay, so x is the input, and this x is passed through a function called f. So after passing through the function f, no more x is x becomes y. So this is what is happening in the computation, and the resultant is called as consequent. Okay, so computing can be thought of as something like mapping. It maps input to an output based on some function. So f is a mapping function which maps the input to an output. So there are different other ways of defining computing also, which you might be familiar. Like like computing can also be called as processing. It takes an input, processes it, and produces an output. Right. So so the input does not make any sense. It won't be. It will be meaningless, but the output will be meaningful. It makes sense. Right. So in computing, some action is performed. This action, what it does in the sense, it maps the input to the output. Okay, fine. And what are the characteristics of computing? So here we are discussing the characteristics of computing. We have not yet discussed. We have not yet entered into what is soft computing, what is hard computing, all those things. We are just discussing about computing. So what are the characteristics of a computing? A computing should provide a precise solution. So when you perform some computation, the solution should be accurate. Okay, and the control action should be unambiguous. Control action means the 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 process of computing. The process of computing should be unambiguous, and it should be accurate. Okay, and it should be and computation can be done only for the problems which can be mathematically modeled. So computation can be done only for those problems for which a mathematical model exists. If there is no mathematical model exists, then you cannot compute at all, and then you cannot get a precise solution or an accurate solution. Okay, so these are the characteristics of computing. It should provide a precise solution. Its action, control action, should be unambiguous and accurate, and the problem, and you should be able to mathematically model the problem so that you can perform the computation. Okay. If the problem cannot be modeled mathematically, then obviously it cannot be computed, right? So now let us try to understand what is meant by hard computing. So before going to soft computing, let us try to understand what is hard computing. Then we will go to soft computing. So the term hard computing was introduced by LAZA in 1996. So according to him, hard computing is defined something like this. So so whatever we have discussed here about computing, so computing is nothing but it is very much similar to hard computing. So hard computing is one which should produce precise result. It should guarantee precise result, and its control action should be unambiguous, and we should be able to mathematically model the problem. So all the characteristics that are applicable to a computing, it is also applicable to hard computing. So generally whatever we say as computing is nothing but we are talking about hard computing. Okay. So hard computing means such computation should produce precise and guaranteed results, and their control action should be unambiguous, and also uh, the problems on which you are going to apply hard computing, those problems should be formally defined. That is, you should be able to provide a mathematical model for those problems. So uh, so such computations are called as hard computing. Examples, so these are the typical examples for hard computing: solving any numerical problems, finding the roots of a polynomial, integration, all searching and sorting technique, finding the shortest path in a graph. Okay, all these comes under hard computing, because for all these problems there is a precise result, and there is no confusion, there is no ambiguity in solving these problems, and all these problems can be mathematically modeled. So the problems which can be mathematically modeled, and the problem for which there is a fixed solution or a precise solution, such problems can be solved using hard computing. Okay, right? But there are certain problems which cannot be solved using hot computing. In real time, there are certain problems which cannot be solved using hot computing. Okay, so in real time, if you see, all problems does not have a precise solution, and you cannot mathematically model all the problems, and and you cannot say that these problems are unambiguous. No, it may be ambiguous. Different times the problems may differ, they may behave differently. Okay, so in real time, we cannot provide a hard computation to all the problems because of the wide variety of problems which we encounter. For example, if you take medical diagnosis, when you diagnose a person when a doctor diagnoses a person for a particular disease, there is no reason that the doctor cannot 100% he cannot say that the I mean the symptom is because of this disease. No, it is something like a probability. It is something like a probability. So in such cases, hot computing cannot work. Or if you say person identification or computer vision problem, which is used to identify face recognition or something like that, here also you cannot, the system can only say that up to this probability 90 percentage this face is matching this person, like that it can say, but it cannot say 100 percentage this is that this image represents that person only, like that it cannot say. Okay, so these are some of the problem which cannot be handled by using hot computation. Similarly, if you see character recognition, so when you say character recognition, somebody may write a in one style, somebody may write a in different style. So the character recognition software can only work based on probability. It cannot say anything precisely. Similarly, pattern recognition, weather forecasting, VLSI design, network optimization, all these are problems which cannot provide, all these are problems where a precise solutions cannot be provided. So, so you cannot go for hard computation for these type of problems. Okay, so this is the reason why we are discussing something called a soft computing. What are the characteristics of a soft computing? A soft computing does not require any mathematical modeling to solve a problem. In case of a hot computing, a mathematical model is required, then only you can solve a problem. Whereas in case of soft computing, the mathematical model is not required to solve the problem. Okay, and the solutions that are provided by the soft computing, it may not be the precise solution. When you talk about the solution provided by the hot computing, it will be very precise and it should be accurate. But here you may not need a precise solution. You need a solution uh, which is quite okay. That's it. You don't need a precise solution. Okay, and uh, the algorithms are adaptive. That is, here the algorithm should be adaptive. That is, it should adjust itself according to the environment. Okay, so there are some biologically inspired algorithms or methodologies which are used for soft computing. So so they are basically inspired from genetic evaluation, like ants behavior, particle swarming, human nervous system. Okay, so some of the algorithms which we use for soft computing are called as particle swarm optimization algorithm, artificial neural networks. All these are some of the algorithms which comes under soft computing. So basically, soft computing is applied to those class of problems for which there are no precise solution, and and these algorithms should be adaptive with respect to the environment. That is, the problem itself may not be unambiguous. It may behave different way at different circumstances. Then the algorithm should be able to adopt. Okay, fine. And then what is hybrid computing? So it is a combination of hot computing and soft computing technique. For some problems, we may apply uh, some techniques which is a combination of hot computing and soft computing techniques, right? That is for a certain for certain part of the problem you may apply hot computing, whereas for the rest of the part you may apply soft computing. So such problems, solving such problems, we use something called as hybrid computing. Okay, right? So uh, yeah. So before that, let me discuss something. Let us formally define what is meant by soft computing. So this is how soft computing is defined. Soft computing is a collection of methodologies. Soft computing is a collection of methodologies that aim to exploit the tolerance of imprecision. See, this word is very important. Tolerance of imprecision and uncertainty to achieve tractability, robustness, and low cost solution. That means what? See, in hard computing, the result should be accurate, whereas in soft computing, the result may not be accurate. That is, the result may not be precise. It can be imprecise also. So soft computing allows it tolerates imprecision. It tolerates imprecision to a certain level, to a certain degree, and also it allows uncertainty to a certain level or a certain degree. Okay, that is it is not that if this is the input then this will be the output. No, the output may change, or if whatever the output we say, it is not that is true in all cases. No, it is a probabilistic output, right? So that is what this says. Soft computing is a collection of methodologies that aim to exploit the tolerance of imprecision and uncertainty. Okay, so these class of problems, the solutions for these class of problems allows certain degree of imprecision and uncertainty. Okay, to achieve tractability. Why it should allow imprecision and uncertainty? To achieve tractability, robustness, and to provide low cost solution. Okay. Otherwise, if you try to solve these problems using hot computing, it would be very tough. And even if you are able to solve, the cost involved will be very high. The cost involved will be very high. Okay. And the principal constituents of soft computing, or you can say the techniques or the algorithms or the or the various methods that are used in soft computing were fuzzy logic, neurocomputing, and probabilistic reasoning. So these are the key terms which are connected with soft computing. How soft computing is achieved in the sense using these techniques, using fuzzy logic, neurocomputing, and probabilistic reasoning. The role model for soft computing is human mind, because this is how the human mind or human brain works. So human brain does not always works based on hard computing. We don't want accurate result. We want a result which is highly likely to be correct. Are you getting? Say for example, when you move out of the home, if the weather is somewhat like rainy, you may take an umbrella and come out. That doesn't mean that only if 100 percentage, if you are guaranteed that there will be a rain, you will take the umbrella. No, no, it is something like a probabilistic. Okay, it may happen, so I'm taking it. So soft computing is also applied to such type of problems where where you cannot provide a precise solution. So these techniques will tolerate imprecision, and also it tolerates uncertainty to a certain degree. So these are some of the example problem for which soft computing is applied. Say for example, character recognition. Say different person may write a particular character in different style, but the algorithm should be able to understand that this all these things represents this particular character. Okay. Uh, now now the algorithm cannot say that everybody should write exactly like this only. No, no, so that is not possible, right? Different users will write in a different way. So the computing, the here now what the computing should do, the soft computing should take these inputs and you should try to map with this output. Okay, so it approximates, it just assumes that okay, it is somewhat equal to this, so it will assume that okay, this is equal to maybe 90% accuracy, something like that it will give, right? Okay. Similarly, this is another type of problem. Say a person want to, so this type of problems are solved using artificial neural networks. So this is character recognition. This is normally done using ANN, artificial neural networks. This is one type of soft computing. Here a person is having money and he want to invest his money in different banks. He don't want to invest in one bank. He want to invest the money in different bank and to achieve maximum return. Okay. So different banks may have different scheme, right? So based on that, his money should be distributed in different bank for different schemes. Okay, maybe in this particular bank, in Central Bank of India, he may put some amount under fixed deposit. Okay, maybe in another bank he may put some amount for what you call uh, the pension plan or something like that. So like that he will, like that he want to invest different amount of money in different banks so that his return will be maximum. Now you need to write a program to find that. So you cannot do this with hard computing, you have to go for soft computing. Okay, so 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 this type of problems can be solved using a technique called evolutionary computing. Evolutionary computing. Okay, whereas for solving this type of problems we use ANN, artificial neural networks. Okay, and here there is a robot, and this robot should move from one point to, say this is the source, to destination. Here it should move, but in between there are many obstacles. All these red dots are obstacles, so it should move such a way that it should not hit any of the obstacles. It should not hit any of the obstacles and it should move. How it can be done? So to solve these problems we use a technique called fuzzy logic. Okay, so these are various techniques of soft computing: neural networks, evolutionary computing, and fuzzy logic. All these are different techniques in of soft computing. So evolutionary computing basically it uses something called probabilistic reasoning. Right? Okay. So there is also something called as genetic algorithm, which is also one type of soft computing. So how genetic algorithm works in the sense, mm, it starts with a random population. Okay, what is population in the sense? Uh, See, population in the sense you can say it's a set of solution, and from this random population it reproduces another population. next generation. Okay, and then it rank the population and select the superior individuals. Okay, here so so genetic algorithm works based on this principle. Here population is synonymous to solution. Population is nothing but solution. Okay, and selection of superior solution is synonymous to exploring the optimal solution. Identifying the superior solution means it is to identifying the optimal solution. Okay, so initially for a problem, say there is a problem P1. For this problem, you are identifying some 10 solutions. Okay, using any one of the soft computing techniques, there are 10 solutions available. Okay, but you want to identify some solution which is better than this 10 solution. Then what you do is you have to do next, you have to go for reproduction. So how you reproduce, in the sense you rank all these solutions. There are 10 solutions, but you rank. Maybe the rank of the first solution may be 4, the rank of the second solution may be 2, the rank of the third solution, like that you rank all the solutions. Now take the top 5 ranks, and using those 5 ranks, say 10th solutions rank is 1 and 8th solution rank is 2. Take this 2 solution, 10th and 8th, and using this you produce another solution, that is called as reproduction. Okay, so see, 10th solution rank is 1, 8th solution rank is 2. So when you combine these two solutions and you create another solution, say that is solution 11th, so it is highly likely that this solution uh, will perform much better than other solution. Okay, like that you take the solution with what you call with third rank and fourth rank and create a new solution Okay, so this is called as reproduction. So now, say now you created like that some uh, 3 solutions, 11, 12 and 13. Now you see whether these solutions are better than these previous 10 solutions or not. If any one of these solution is better than this previous 10 solution, and take that. And then again you see, are you satisfied with this solution or not. If you are satisfied with the solution, stop the process. Otherwise, if you are not satisfied, again reproduce. Again from 11 and 12 you produce another solution, you can call it as 14. From 12 and 13 produce another solution, you can call it as 13. Okay, check its performance, how it performs, whether it is performing better than the previous solution or not. Or are you happy with this solution? If you are happy, you stop. Otherwise you continue doing this process. So this is called as genetic algorithm. Where we take a random population. Using this random population, you produce another population, then rank the population and select the superior individuals, which is nothing but superior solution. Okay, so this process ends once you are happy with the solution. So once you feel that okay, this solution is fine, then you can stop. If you are not happy with the solution, again you produce another set of, again you reproduce, again you compare, like that it continues, right? So that technique is called as genetic algorithm. And here is an example for fuzzy logic. See how a doctor will treat his patient. Doctor will ask the patient like what is his problem, and the patient will explain. Okay, so based on the input given by the patient and based on the symptoms, the doctor will predict that this is the disease. Okay, and and based on that, the doctor will prescribe tests and medicine. So whatever the input the patient gives, and whatever the symptoms the doctor observes, based on that he predicts that this will be the disease, this may be the disease, and accordingly he'll ask the patient to go for test and go for medication. Okay, but is there is any guarantee? Is it 100% guarantee that the doctor's prediction is correct? No, there is nothing like that. Okay, so this type of problems can be solved by using a technique called fuzzy logic. Okay, because symptoms are correlated with diseases with uncertainty. Okay, so there are some symptoms, and doctor predicts something, but there is some uncertainty. It is not that whatever doctor predicts is exactly correct. There is a degree of uncertainty. Okay, so doctor prescribes tests and medicines fuzzily. Fuzzily means based on his experience and based on his understanding he prescribes, but 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 there is no way the doctor to guarantee that this is exactly this problem. Okay, right? So these type of problems can be solved by using a technique called fuzzy logic, right? So here is a brief differentiation between hot computing and soft computing. So hot computing requires precise solution. Okay, that is, it requires a precise analytical model, and it needs a lot of computation time. Whereas soft computing is tolerant to imprecision, uncertainty, partial truth, and approximation. It allows approximate solution. That is the specialty of soft computing. Okay. So hot computing, to implement hot computing, we use binary logic, crisp systems, numerical analysis, and crisp softwares. That is, your result should be accurate. Crisp means the systems which provide accurate results. Okay, whereas soft computing is based on fuzzy logic, neural networks, and probabilistic reasoning. Okay, so the hot computing, its characteristics are precision and categoricity. So the result should be precise, and it should be very categorical. Okay, whereas the characteristics of soft computing are approximation and disproportionality. Hot computing, it is deterministic, that is, you can tell this is the result exactly, whereas this is stochastic, means it is probabilistic. It requires exact input data. The input, if the input is, if any of the input is missing, then hot computing cannot work. Okay, say for example, you want to find the what you call area of a circle, then you need radius. Without radius you cannot find, right? So that is actually an example of hot computing. Whereas in soft computing, it can deal with unambiguous and noisy data. It does not need all input should be accurate. Some input may not be accurate also, but still it can work. It is strictly sequential hot computing. So it allows parallel computations. Okay, hot computing produces precise answer, but soft computing produces approximate answers. Right? Okay, so that's it, particular lecture. Fine, let us stop here. So here we have discussed a brief introduction to soft computing. Thank you.